because we have basic people learning. Shut up! Oh God, it reminds us. Basic. Hey, me, I'm just going. Wait, remember, I'm going. Basic skills.
Hello, everybody. This is the recording for the K-5 breakout room from the Nebraska Phenomena MINK webinars. Thank you for joining me. I am Betsy Barrett. I teach middle school at Norris Public Schools in Nebraska. We're just south of Lincoln. If you want to get in touch with me, you can email me at betsy.barrett@nsdtitans.org or get a hold of me on Twitter. My handle is @bbarrett. And so we're going to start talking today and learning about what makes a phenomenon academically productive. Some thoughts I have about what makes a phenomenon academically productive are that when students see a phenomenon or observe a phenomenon, they start asking questions, and those questions that need to be answered can be answered with those science ideas that are in the standards that we're aiming at helping students learn and figure out. One of our other participants mentioned that a phenomenon that's academically productive is one that students can continue to plug back into, and I really liked that analogy. In other words, academically productive phenomena are not just a hook. They're not just something that you start with at the beginning of a unit, but it's a phenomenon that's academically productive, actually drives questioning and learning and figuring out throughout the unit. So we're going to see today if we can figure out whether a phenomenon is academically productive or not. And we've got 3 steps to our process here. The first is to analyze the standards. We're going to really pull them apart and take a look at what it is that students need to know and be able to do. Then we're going to take a look at 2 phenomena that may or may not be academically productive for a bundle of standards. And 3, we're going to create some student explanations for the phenomena to see how well they align with what we've unwrapped and the student claims that we've written, and really make a decision about whether that phenomena would be academically productive or not. So here we go. Our first step, like I said before, is to analyze the standards. And what I want you to do right now is just take a moment to think about, why do we analyze standards? What's the point? Why not just go straight to the evidence statements and look at how the architects of our standards pull them apart? My thoughts on this are that it's really important for us as teachers to do the digging, to pull the standard apart so that we have a good understanding of what it is that students know and are able to do and what it is they need to be figuring out. Some of our standards are really complex. I like to use the word loaded. They just are full of things students need to know and be able to do. So it's really important in this analysis process that I, the teacher, am making sense of the standards so that I can then in turn help my students figure out the phenomenon and which science ideas they're going to need to be able to figure out that phenomenon. As we start analyzing our bundles, and in particular a standard, I think you're going to find that your brain starts trying to relate these science ideas to events in our universe, and you're going to start brainstorming ideas about phenomena that might work. So some guidelines for analysis are that we're going to use the framework as a guide, it's really important that we try to not bring our own ideas or facts into what it is that students know and are able to do that aren't actually called for by the framework, by our standards. We've got a tool, it's a Google Doc, that's going to help us to unwrap those standards, and we'll be walking through how to use that today. We're going to try to then take what we learned from the unwrapping to create some student claims, and those are going to be really helpful for when we're trying to decide what phenomena might be academically productive and which ones might not. When we write those claims, we're going to think about two different things. We're going to consider facets of knowledge or different aspects of ideas that are in that standard that need to be represented. And we're also going to consider prior knowledge students that would have to have coming in to figuring out that phenomenon. We're going to really try hard to not write definitions. Remember, we want to be thinking about concepts. So I have chosen a bundle for us to take a look at and figure out, and it happens to come from 4th grade. It's 2 of our earth science standards. The first one is ESS 2-1, make observations and or measurements to provide evidence of the effects of weathering or rate of erosion by water, ice, wind, or vegetation. Whew, and that's one of those that I feel like is loaded. I know when I read that to myself, there's lots of ideas there that I need to really dig into. And then the second one is for ESS 2-2, which is analyze and interpret data from maps to describe patterns of Earth's features. So remember, we want a phenomenon to drive student understanding, student figuring out in both of those areas. But we're going to only unwrap one standard at a time. So I chose for us for ESS 2-1, the one that is really loaded. So let's go ahead and take a look. We're going to start, like I said, by unwrapping this and using a template. So let me show you what this template looks like. And by the way, I have included the links to this document in the hub, the MINK hub. So if you are looking to get to this document, go to the MINK hub. So you're going to see it is a Google Doc that breaks parts of our standards. Let me back up. You're going to recognize parts of our standards in this document, meaning science and engineering practices, disciplinary core ideas, and cross-cutting concepts. And you're going to notice these columns down here. We're going to actually be looking for verbs, we're going to be looking for nouns, then we're going to think about the context of what students are learning, and eventually think about rigor. We're not going to take a specific look at that today. We are going to focus on verbs, nouns, and considerations, and then we're really going to focus in on the content context. If we're going to figure out whether a phenomenon is academically productive or not, we've got to really dig deep into the science ideas found in the DCIs. We've got to make sure that we can elicit questions that will lead to the uncovering of those particular pieces of content. All right, so let's go back here. Let me go ahead and go back into presentation mode. All right, so unwrapping. The basic steps are to identify the performance expectation, which I've already done for you, ESS 2-1. We're going to enter the performance expectation into the top section of that Google Doc that I just showed you and add the unwrapped skills, noun, criteria, and conditions. And then follow up with science and engineering practices, disciplinary core ideas, and cross-cutting concepts. Steps 4, 5, 6, and 7, we are not going to cover today. We are going to focus on 1, 2, and 3. And in step 3, we're really going to focus in on the disciplinary core ideas. So just going back to our standard that we're going to focus on for ESS 2-1. And remember, the first step of that process is to transfer the elements, the information from the element boxes to the template. So this is just a screenshot here, but you can see I took the science and engineering practices, the DCI, and the cross-cutting concept, and I just transferred those straight from the standards document into these boxes on that template. And I also had already transferred the standard itself. Next, we're going to start with the PE, and we're going to start to identify and add unwrapped nouns, verbs, criteria, and conditions. And I'm going to walk us through that here. So you can see there's a link to the document here. So let's go ahead and take a look at that. You're going to notice some color coding here, and hopefully that is going to help us understand what's going on here. So we're going to really focus in on just the performance expectation right now. And the first thing we want to do is start to identify verbs that we find in the performance expectation. So I have chosen to highlight those in red. So the first one I found is the first word of the PE. Nice and easy. The verb make. So I coded that red, and then what I would do is I would just take that and copy and paste it down into my verbs column, make. And then I'm going to come back up, and you'll notice that there is actually another verb here, and that is the word provide. So I would go ahead and color code that red, and then I'm going to just go ahead and come put that down in my verbs column. The next thing I'm going to do is really start thinking about the nouns here. In other words, make what? Provide what? So with make, we're going to make observations and measurements. So I've color coded those in purple, and then what I would do is I would copy and paste those down into my noun column. So now I know that my students need to make observations and measurements of weathering or a rate of erosion. And then if we come back to the one that I hadn't color-coded previously, we've got the verb provide. Well, what is it that students have to provide? They have to provide evidence. So let's go ahead and color-code that purple because it is a noun. And then you'll notice I just went and pasted that in the noun column. All right. So we have unwrapped the first parts of the performance expectation, but we're not quite done yet. We want to make sure we pay attention to the clarification statement also. And what we want to do is we want to take a look in this clarification statement to see if there's any context that we might add to our unwrapping document. And these pieces are going to come down, and we're going to put those in the performance criteria or considerations column. So one of the first things that I notice about this particular PE is that in the clarification statement, we have some examples. So those are some considerations that we want to definitely keep in mind as students are learning. So what you're going to do here is take those examples, and you can whittle those down a little bit in terms of, you don't have to use all those connecting words, but you're going to put those into the considerations column. So what they wanted us to make sure we consider are the variables to test, like angle of slope, amount of vegetation, speed of wind, rate of deposition, and so on. So make sure those pieces that you need to take into consideration go into that example column. And then we also need to make sure that if there are any assessment boundaries, those go into the performance criteria for consideration also. And we want to make sure that in here we add And this isn't an example, so this is something, this is just another consideration that we need to make sure we include. We need to make sure we're only talking about one variable at a time. All right. That really helps us think about what kids are going to be doing in our classroom. Okay, so our next steps are going to be to go and follow that same pattern of finding verbs and nouns in the SCP. Again, I highlighted verbs in red and nouns in purple, and then simply transferred them down to my verbs and nouns column. And again, this is telling me, helping me think about what it is my kids are going to be doing in the classroom. They're going to be carrying out investigations. What else are they going to do with that, those investigations? Well, the reason they're doing that is to answer questions. So one thing we might do is add a bullet over here in our considerations that they are needing to answer questions. And so since that those three ideas go together, I'm going to make sure they're kind of lined up across those columns. So I know that they have to carry out investigations, and the purpose, the reason is to answer questions, or one of the reasons is to answer questions. And I've got to take that again into consideration when I am working to plan for what students are going to be doing in the classroom. So I would follow that pattern with the rest of the SCPs. What I really want to focus on with you now, because this is more relative to our goal here, which is to figure out if a phenomenon would be academically productive, is we're going to really focus in on this DCI column and these elements, these bulleted pieces of the DCI elements. So what we want to do here is dig into these statements in the DCI box. And we're going to pull them apart, and we're going to take those ideas and put them down into the content context box. And I'm going to just switch documents here quickly. All right, here we go. So if we come down to this content context box, like I said, we want to pull apart those DCIs into the pieces that are there, because those DCI statements, at least for me, they look pretty loaded. There's a lot of things there that kids are going to have to know and understand and use to create evidence that will help them to explain weathering and erosion by water, ice, wind, or vegetation. I had a great question yesterday during our MINK webinar about, well, why don't you just copy and paste those sentences down into that content context box? And I'm not sure I had a great answer at the time, but as I thought about it, I think it's really important that we don't just copy and paste. I think it's really important that we look at those DCIs and those pieces of the DCI and put them into our own words. You know, just like in the classroom, we want kids to put things in their own words. This process for us, if we're truly understanding and wrapping the standard to the level where we are making sense, and then we can choose an academically productive phenomenon, we've got to start kind of putting things into our own words and making sense out of them ourselves, not just copying and paste what the words were from somebody else. So this first bullet, rainfall helps to shape the land and affects the type of living things found in a region. So for me, there are kind of two ideas there. Rainfall shapes the land, and rainfall affects the types of living things found in the region. So if I come down to my context box here, I'm going to actually go ahead and separate these out. Notice too that I have my limitation down here, and that came from the clarification statements. All right, let's come back up. What's the next idea here? Water, ice, wind, and living organisms and gravity can break rocks, soils, sediments into smaller particles and move them around. Okay, so we've got that long list. I don't think you have to necessarily separate out all of those ideas, but there are two things that are happening because of this. Those things break rocks, soils, and sediments into smaller particles, and those things move those particles around. Okay, so if we come down here, I think the way I would break that apart, all right, is to smaller particles, period. And let's break that up. And then I can just take that list and copy, put that here. All right. I'll just get this formatted here. All right, and then that last piece comes from the second bullet point in that DCI box, living things affect the physical characteristics of the regions. That's pretty straightforward. Paraphrasing that, putting that into my own words, living things affect the physical environment. I just kind of shortened it up, tightened it up a little bit. All right, so we have that content context now. This list of content that comes from the DCI element box is what's going to really help us to decide if a phenomenon is going to be academically productive or not. In other words, is it going to elicit student questions, ideas, and thinking that will involve all of these ideas, these science ideas. All right, to finish up the unwrapping piece here, you're going to go to the cross-cutting concepts and you're going to follow that same routine that we did with the performance expectation and the SCP. You're going to identify verbs, nouns, and any considerations or context that are needed. So one of the things that I noticed is that we've got a couple of verbs here: identified, tested, and used. Now, they are all really going towards an explanation about cause and effect relationships. So we want to make sure we get that represented down here. So we're going to identify, test, and change cause and effect relationships. And we want to use those to be able to explain changes. And that might be changes in the land. It might be changes in living things. All right. So That is the basic unwrapping process. You'll notice that there's more to this document. We're just not going to get into that today because, like I said before, we are really focusing in on these cross-cutting concepts. That's what's going to help us to decide whether a phenomenon is academically productive or not. So let's go back here. The next thing we would do would be kind of a little bit of a check. I would suggest that you go to the framework and find the text there that represents our standards that we're looking at. And specifically, we're looking at the Earth and space science standards and the core ideas are ESS 2A and ESS 2E. So what I would suggest you do right now is actually go read those. I've got the pages here for you, and this is actually a link to the Earth and space science core ideas. And what I would have you do while you're reading is jot any ideas down that you are reading about that you think are important, and try again to follow those guidelines in that you want to not write definitions. We want to kind of think on the conceptual level, big ideas, because what we want to be able to do with those is write some student claims. So let me uncover here. So after you've read the framework, you want to formulate student claims about what students should know after the learning has taken place. And we're going to try to formulate these claims in complete sentences. We want to consider facets of different aspects of the ideas represented, not only from the framework, but from the unwrapping that we did. We want to consider knowledge students would need that is foundational for understanding these ideas. In other words, what do they need to be coming into the class with? And if they're not coming in with that, what do we do? Something we definitely have to take into consideration. And again, we don't want to write definitions. So here are some example student claims from a different standard. So the standard is construct an argument that plants and animals have internal and external structures that function to support survival, growth, and behavior and reproduction. So the facets that were pulled out were that all living things have structures that serve important functions to them. Some of these structures are things we can see. They're external, like hands, arms, or eyes. So you see you've got complete sentences here, and those facets are the pieces of this performance expectation that kids should know. And then prior knowledge over here, plants and animals are living parts of the environment. Plants and animals have some parts we can see and some that are inside that we can't easily see. These prior knowledge pieces might come from their prior learning. In part, it depends on what grade level you're taking a look at. When you're writing these prior knowledge pieces, you might go to the progressions in the framework and look at the progressions of particular DCIs, so you can take a look at what those kiddos, what their foundational knowledge needs to be coming in. But it's important that we think about that. All right, let's go ahead and move on. So I went ahead and wrote an example claim for ESS 2-1, what students should know, and what I felt like the prior knowledge piece was. So one of the facets of this I believe students should know is rain has a big impact on the shape of the land and living things. And prior knowledge coming in is that the land is made of soil. So once you've gone through writing those facets, and by the way, I will share some finished ones with you, you're probably going to find that your brain is starting to think about phenomena that you might use. So I went ahead and picked out 2 phenomena that we could possibly entertain for these particular standards, for this particular bundle. So the first one is a dam in Nebraska breaks, which is incredibly relevant for us here right now. The Spencer Dam broke last week and has resulted in devastating flooding here in the state of Nebraska. The other phenomenon I borrowed from the Wonder of Science website, and it's called biological weathering. So what you would do once you've introduced that phenomenon to people, and let me actually go back and give you a little more detail on those, sorry. So you introduce that phenomenon to kiddos, you show them where the Spencer Dam is, it's on the Niobrara, and then what's really impactful is this image, this changing image from before the floods to after the floods. Okay, and then biological weathering, like I said, I stole this from the Wonder of Science. The main idea here is that the roots of certain trees are able to break rocks over time. So you've got this picture here. You can show that to kids and start your driving question board or having them look for patterns, the way you introduce phenomena. So then what we're going to do as teachers to see if we can figure out whether either of these would be academically productive, we're going to try to write a student explanation. Now this is hard. We want to kind of step out of our teacher role and think like students, and think like students after they've done the learning. How would they explain this phenomenon? So I wrote 2 potential explanations, and I am not going to claim that they are perfect, but this is what I came up with. So I'll let you read those here for a moment. And if you need to go back and take a look at these, remember I've shared my slides with you, okay? So then what we want to do is we want to take that student explanation that we formulated and compare it to the claims that we wrote. So remember before I shared this first claim with you, but I did write other claims that I felt were the things students should know by the end of the learning. And so now what we want to do is we want to compare this explanation to the claims. Are they similar? Are the science ideas that are in the explanation the same basic science ideas that are in our claims? And that's when you make that decision. Is it a match? Let's take a look at the second one, the biological weathering. Here's my student explanation. Same claims, because we're coming from the same standards, and we want to compare and contrast here and try to make a decision. Is it a match? So based on whether you said yes, it's a match, or no, it's not a match, that's really going to tell you if that phenomenon is going to be academically productive or not. If you said yes, this is a pretty good match, or it's good enough but maybe not perfect, good enough but not perfect, stealing that from TJ McKenna from our first our first webinar series, then that really tells you you can use that phenomenon to drive student learning around that particular standard or a bundle of standards. If you're thinking, no, it's not a very good match, then that is probably not a phenomenon you want to select. All right, that's a lot that I have shown you in the last however long this has taken. Please make sure that if you've got questions, you reach out, email me. Remember, I have included the resources that I used in this presentation on the MINK webinar hub. And happy phenomena-ing. Hope you are all well. Take care.